Hey everyone, welcome back. For those who don't know me, I am Prajwal Aluwalia and I've been building PRISM, a system design simulator. While building it, I've ended up designing dozens of systems, and today I want to walk through one of the most common system design interview question, design Instagram. But instead of starting with a huge architecture diagram, we are going to start simple and improve the design one step at a time. Every time we hit a bottleneck, we'll fix it. And by the end, we'll see whether our architecture can actually survive millions of users. So let's get started. Whenever I approach a system design problem, I don't try to build the final architecture immediately. I start with the simplest version that works. So let's assume user can upload photos, view their feed, like posts and comment on the post. So for version 1, we'll keep things extremely simple. Now user send the request which passes through the load balancer and then goes to our application server and then hits our database. Simple. Okay. Now what if we run the simulation? We'll see there are a lot of production risks, which is evident, right? Now how do we make it more scalable? Right now it's simple and functional, but it is very terrible at scale. So we'll identify the first bottleneck. So let's think about what happens when Instagram starts growing. What's the biggest problem here? User uploads, right? Images and videos. Images are very large, videos can be larger, right? Databases are expensive. So storing million of photos directly in a database is going to hurt the performance very quickly. Okay. So to tackle that, we store media in the blob storage and we place a CDN in front of it. So here's a CDN and here's a blob storage. So whenever the user request these images, they don't need to hit our database directly. What will happen is they will get to hit the CDN first. It will serve most of the requests directly, and that CDN will access our blob storage. So this reduces latency and removes a huge amount of load from our backend. Now next, we need to focus on what Instagram actually does. Okay, we check the traffic patterns. Instagram is heavily read oriented. Millions of users consume content daily, right? But only a small percentage of that uploads content. So what can we do? So instead of treating all our requests equally using just one server, we'll separate the read and write. So right now this server, and we can add one more server, okay? And each of these server will have its own functionality. Right now let's remove this connection. So this server will be considered as a read one, and this server can be considered as the write server. Okay. There's a spelling mistake and it's fixed. Cool. So millions of users are requesting requesting the same data. Cool. So instead of treating all the requests equally, we distributed them as read and write. So what will happen? All the read requests will go to our read server and all the write requests will go to our write server, which separates these requests, and I'll say a lot more of traffic can be distributed and a lot more of load can be removed from just using one server. Now we are going to face the new problem. Let's say we have celebrities joining our Instagram now, right? So people will obviously follow their favorite celebrities. Some of the celebrities will have millions of users. What happens if they post a picture? Obviously that post is going to go viral, and millions of users are going to, that 1 million user will be, looking for their post and they want to see what they have posted, right? So it will increase unnecessary load on our database because all the requests will be hitting our database. So to rectify this problem, we will be using cache. So the popular content gets served from this memory, the cache, and it will save unnecessary hits to our database. So our read will go through the cache and it will go through our database. Okay. Now what will happen is there will be a less database pressure and better user experience. So we are done with our viral post as well. Now we are going to solve the infrastructure problem, but we still have a product problem. How do we generate the Instagram feed? Because every user follow different people, right? So every feed is going to be unique, and generating feeds in real time becomes expensive very very quickly. So instead of generating feed synchronously, we'll move this work into a queue. Okay, so we'll just add a feed generation service. Feed generating service. Okay, now there will be a dedicated workers which will run around clock to give you your particular feed, and it will be like more personalized. So what will happen is that this keeps user facing requests fast while heavy computation happens asynchronously. Okay. So we're going to move everything inside a queue. So what will happen is we'll select a queue from here, and as we don't have enough space, I can move it right here. Okay, this queue will be named as feed generation queue. Okay, we can move it here, and we'll just connect it with this one. Okay, now this keeps user facing requests fast while heavy computation is happening synchronously, right? Now photos are very easy to manage, right? But videos are not. Videos need compression, transcoding, multiple resolutions, thumbnail generations, and whatnot. So we definitely don't want users waiting for that work to finish as well. So this process will be asynchronous as well. So similar to the feed generation queue, we will have video generation queue as well. So this will be video generation queue. Okay, now what will happen is uploads enter a processing queues, and worker consumes jobs and processes videos all in the background. Okay, so what will happen is same video generation queue is here. Now video generation service will also be in place, and obviously it will also work around the workers. Okay, so I'll just pick up one worker from here, use it, and voila. Now these videos needs to be shown to the users quickly as well. So what we will do is we'll connect it with the blob storage. Now to make it more easier to understand, what I'm going to do is going to move all these things above. Okay, the server read will come down, there will be database, server write will be like this, and our blob storage will go above, workers will come here, and voila, we have a better looking system right now, correct? Now if we have generated the feed as well and the videos as well, we need to save them in a database, right? So we will store it in a database like this. Now do you think a single database will be taking all the loads? Yes, it will. So what we are going to do is going to make it primary database. Okay, and over here we'll start primary, select primary, and then we will have more databases which will be a replica database. Okay, so the type of these will be replica and replica. Okay, so this is the basic architecture of how the Instagram actually works. Okay, now we can do one more thing, like we can add the functionality of searching. Okay, so search systems are optimized differently from databases, right? Databases are great for storage and search engines are great for discovery. So we'll introduce a dedicated search index. So what will happen is we will have a search index with us, which will directly go to our database primary, and it will be connected to our read server. And now we have something that looks much closer to a real world system. We have CDN, blob storage, read write servers, we have our caching, we have our search index, we have our database, and we have our generation services, right? Now this architecture diagrams can be misleading. Just because something looks good doesn't mean it scales. So let's put this thing to test. Now we are going to first submit the evaluation. Okay, we see it is scoring 75. Now what we will do is we will increase the number of users. So let's say 1 lakh, and each user requesting one request per time. And now let's submit the evaluation. So we can see the score dropped. There are some issues which are just mentioned over here. Now you can come here, you can check for all these issues, then run the fix your architecture, then run the simulation again and whatnot. And one more thing you can do here is you can come over here and discuss your issues with your peers. Let's say your simulate tells you this thing, so we can ask this as well. How to fix, I caught this error when I increased my user count from 100 to 1000. Please help me resolve it. And then you can just post this question and someone can come up and help you with solving this question. If you have any answer, you can just reply, hi, I have a resolution, and whatever resolution you want you can put it up. So this is how it will go. And now you can also come here and check for the submissions that you make. Okay, it will have all your scores, what the latency is and what the status was. So mostly if you are scoring above 70, it will be accepted. If it's below 70, it will be in the review state, and so on. Okay, so everyone, this is our Instagram architecture, and more importantly, we didn't start with the final diagram. We started simple. We found bottlenecks, we fixed them, and evolved the system step by step. And that's exactly how system design interviews work, and honestly, that's how most real system evolve too. If you'd like to see more videos like this on WhatsApp, Uber, Netflix, or YouTube, let me know in the comments, and I'll see you in the next video. Thank you.